Alrighty, so some examples. Mean, median, and mode here. And again, the mean equals the sum of the data values divided by the total number. That's your average. Median, smallest to biggest. It's the middle one or the average of the two middle ones if there's an even number of numbers. And mode is the most frequently occurring. There can be more than one mode. There can be no mode. We can use mode when it's non-numeric. So instead of counting the number of chickens, we could talk about the color of the chickens, or how many eggs they lay, or any number of things like that don't have to be numbers technically, I guess. So first one here, finding measure of central tendency. Some bowling scores. Kind of already did this one, I guess, for you, huh? So we see here the mode. So mean, median, and mode with the same set of data here. Again, mean, add them up, divide by the number of numbers. Median is line them up, and in this case we had to average the two middle ones. And then mode is the most frequently occurring. So here, now we talked about throwing out the outlier. So it says consider the scores from problem 1 that do not include the outlier 189. Redo your mean, median, and mode then. So again, if we decided to cross out that 189 because it's an outlier, I never bowl that good. Then recalculate them. And so we get a new mean, a new median, and a new mode all down here. And now that we've redone that, we decide, okay, which one best represents the data. And again, if you were to list them smallest to biggest like we've done here, just a second, I'll pop that in. So again, here they are, smallest to biggest, and we can obviously ignore this stuff down here. So, not this one though. That's your outlier, throwing it out. So here's smallest to biggest without the outlier. We can see that 112 is kind of about in the middle of them all. So 104, 104, 109, 112.4, 113, 117. It'd fit right in the middle. So there you go. Not a bad measurement in this case. I love this kind of problem. You've seen these before. Finding a data value. So your grades on 3 exams are 80, 93, 91. What grade do you need on your next exam to have an average of 90 on the 4 exams? So your scores that you know, your unknown score of X divided by 4, because it's actually 1, 2, 3, 4 this time, and you want equal to 90. Now we could have greater than or less than or equal, which you've seen on quizzes and tests. Then we just solve. Add up the ones you know, and then it becomes a multi-step equation. I go ahead and I multiply off my 4, subtract up my 264, and I have to have a 96 to reach that 90 this time. 96, or better if you want higher. Alrighty, so kind of the same problem this time. We have an 80 and a 93 and a 91 and an unknown score of X. Those are 4 scores, and I want an 88 this time. So again, my solution, add up the 3 numbers here and get 264 plus the unknown score of X divided by 4 equals 88. Divide off my 4. So again, multiply off that 4, and I get 264 plus X equals 352. Whoops, there we go. Subtract off my 264 from both sides, and we get X equals 88. So this time I have to have an 88% to get an 88% overall. Well, there you go. Now part B of this, you can do the same thing. So you're going to have that, you're going to have your 80 plus your 93 plus your 91 plus your unknown score of X, again divided by the 4 scores, and you want to get, raise your average to a 92. So you do the math on that, and you're going to find that you have to have a 104 or better. And if the max is 100, you can't do it. So maybe the teacher takes some pity, gives you some bonus. Don't know. Alrighty. So there again, there's the work for that one. Range, a little less work here. Finance, the closing price in dollars of 2 stocks for the first 5 days in February shown below. What are the range and mean of each set of data? So use the results to compare. So again, mean is just that average, right? Add up the 5, divide by 5, get 32. That's in stock A. Range is 22. That means again it's spanned from from the smallest to the biggest by a total of 22. Stock B, again, range is 8, so a little bit tighter, right? And the mean here, the average is 32, so it didn't vary by as much in stock B. That's what that smaller range tells you. So again, both sets of stocks have a mean of 32. The range for A is 22. The range for B is 8. They had the same average price, but the stocks for A were more spread out again. So B was a little more reliable, maybe. That's one way to look at that. And I do ask you test questions about this, like who is a more reliable bowler or golf scores, things like that. Alrighty, so for your got it here, for the same day, the closing prices in dollars of stock C, 7, 4, 3, 6, and 1. And as you can see here, we added those up and divided by 5, got 4.2, and subtracted for the range and got 6. For D, they were 2, 5, 10, 15, and 24, which is added together, you get 56, divided by 5 is 11.2. And then the biggest minus smallest, 24 minus 2, is 22. So what are the range and mean of each stock? Use results to compare them. Well, all kinds of things can be said. D had a range of 22 and a mean of... So again, what we're looking at here, kind of a blurb there in the middle, is just making comparisons. You can say that overall D has a higher average, but a larger range, so it's a little more volatile, and C has a smaller average, but again, it's a smaller range though too, so it's less volatile. So it depends on how much money you have to invest, I guess, in this case. Now this is the next example, adding a constant to a data value. The table shows the time several athletes spend on a treadmill each day during the first week of training. The athletes had 5 minutes during the second week. What are the mean, median, mode, and range of the time for the second week? So in other words, here's their first week, right? And you go ahead and add on 5 to each one here, so 30. So again, adding 5 onto the mean, median, and the mode when you're adding 5 onto each one. So just adding a constant to the overall. The big thing here to note is that the range doesn't change. You bump up by 5 on bottom end and top end, and it doesn't change anything. So in the third week, we're adding 10 minutes on to each year times from the previous week. So again, they each go by 10 this time. Not really rocket science here. Mean, median, mode, and then range in that order. Alrighty, so we've got here is multiplying by a constant. Instead of adding a constant, multiplying by a constant. So store sells 7 models of television. The regular prices are these. This week the store is offering a 30% discount on all televisions. What are the mean, median, mode, and range of the discounted prices? So we can find here mean, median, mode, and range using the original prices. And we can easily then multiply the mean, median, mode, and range in step 1 by 0.7 because you're paying 70% of the price if you're taking off 30%. And that's what we do. So, and the reason this works is basically we're kind of looking at distributive property here, really. So you can just take each of your others and multiply them by that same 0.7. Okay, in this fifth example here, same kind of thing. Only this time they're giving a 25% discount. So you're going to multiply each by 0.75. So if you look back at the last slide, that's really all we're doing here. And you get a new mean, median, mode, and range based on that.